Hello. So in the previous episode, we ended with the Kaby Lake being enhanced process, enhanced clock speeds, improved graphics, support for faster memory, native support for USB 3.1 and Thunderbolt 3, and optimized video handling. Meaning we are still talking about Intel and Intel being in the mech side of the processing and still not doing anything for the last couple of years. And we are going to hopefully, and I say hopefully, finish with the Intel talking in this episode.
Why? It's been good?
Yes, the idea is that we want to get this thing finished and come to the part where Intel actually did something new and try to paint the picture why Intel had to do it. And also try to understand how did Intel came up with the new architecture so quickly.
I'm going to fall asleep. This is the longest intro ever.
Yes, so let's roll it and then let's come back to the talk.
Okay, now with your circular motion in intros, which was awesome. Just so typical. So, Kaby Lake, you want to start or should I?
Let me create a challenge for you.
Okay.
Try to explain Kaby Lake to me as it is, as if it was interesting.
I can't even if I tried.
Yes, I know. This is one of those things where Intel did something that actually made sense. They created a new generation of the processors.
There's actually just one thing. The huge bump in speed.
Yes.
In terms of frequency.
Yes, but this was just simply because they were able to boost the clock because they were boosting the technology and the process that was taking them to that they were using, so 14 nanometers process. The thing is that they probably the most important thing, or the thing that actually remember that makes sense, that the process itself was marketed.
Mm-hmm.
And once a chip producer, whatever the chip producer is, or the manufacturer of the processors, as they called, starts marketing the process in which the processors are being produced,
this thing is not good.
They have nothing else to add. So this was done in 14 nanometers plus. The thing that is bothering me is that when you say 40 nanometers plus, you're usually meaning more than 40 nanometers, not the thing that everybody thinks that you're doing.
That's tech marketing for you.
So it was supposed to mean that they made improvements, but making something bigger in chips is usually not an improvement. So let's call it a B- for the marketing, and let's move on.
The only memorable part was a hugely optimized media engine. That's it.
Yes. So then came the Coffee Lake.
Okay.
And the reason why I mentioned the 14 nanometers plus is because Coffee Lake was done in 14 nanometers plus.
Mm-hmm.
So
buy two, get free.
Yes, and this is the thing that I would say was bothering me, but I slowly moved away. This was a time when I slowly moved away from the talking about processors, and I stopped caring.
Completely.
Yes, I just became a user, and this was just an amusing fact. When they said, okay, we are now reintroducing the same thing that we introduced in the last generation, and the last generation was reintroducing the same thing that we introduced in the previous generation.
Okay.
This was something that, okay, I said, okay, I was reading the data sheet and said, okay, faster, obviously, more cores. Okay.
The only important thing is more
cores. Okay. Mainstream desktop with 8 cores. Okay. 16 cores with...
up to 12, I think, if I remember correctly.
think
But
I
okay.
think that was the mainstream was the idea.
Okay.
The idea was that previous to this, only the high end or the highest end i9s were 8 cores or plus, and now the mainstream suddenly became 8 cores, which meant that Microsoft, who was also immensely behind the technology, had to create Windows that made sense. Because I want to also say that this was roughly the time when Windows 10 was introduced.
You want to say that Windows 10 makes sense?
No, but I want to say that they make more sense than the Windows 8.1.
If you said 8, I would agree. If you say 8.1, I don't agree. But okay.
Okay, let's ignore the thing that didn't exist, so Windows 8.0, and let's say that 8.1 was the Windows that was current, and then it was the Windows 10 was introduced. If I remember correctly, I may be wrong on the timeline, but you're going to check. But the thing is that this was when I turned into
Windows 10 2015, July 29th. Actually, it was a little bit before that.
A little bit
but okay.
before, but this was when I was I would say that I was using Windows 10, and I was using the Windows 10 on my 4790K.
One of many.
Yes, no, this was actually the one that I actually paid for. So this was my home computer way back then. Also, this was when was the Coffee Lake introduced?
2 generations after that.
Yes, but what was the year?
2017. Oh, I mean, misunderstood you. 2017.
2017. So this was basically the time when I actually switched to being an actual user, and stopped caring about Kaby Lakes, Coffee Lakes, and so on, and just said, okay, I'm waiting for the processor that will make sense.
Okay.
By making sense, I meant something that is not going to be awfully expensive.
Okay.
Something that is not going to be trying to make money out of to squeeze money out of me by simply stating that they have i3, i5, i7, i9, then I don't know how many models across the line, and the difference is going to be negligible. So basically, what I was doing, I was waiting for an AMD. Okay, now to you.
Yeah, I just want to add one thing,
Yes.
which I find to be significant for the Coffee Lake generation of the CPUs, and it's nothing to be overly enthusiastic about, but it's still important to understand from the perspective of timeline. Do you know in which products was Coffee Lake prominent and which products were very much a marketing tool for Coffee Lakes?
No, not from the top of my head.
Yeah, one of the most important platforms for that was actually one of the last MacBook Pros.
Ah, okay.
That was where it really shined. I have a laptop with from that generation that still works really well. Absolutely no intention of changing it for all of the aforementioned reasons in some of the previous episodes. But it was a thing of beauty at the time when it was released. Worked very well on MacBooks. It worked well with Windows as well. But even back then, I was very much familiar with the good old joke that we've been saying for the past 8 or 9 or 10 years that the best Windows laptops were in those days MacBooks. It still stands to this day.
It doesn't, because the Windows is limited to
You know what I'm talking
ARM,
about.
to ARM that they are only supporting, so they are limited to Snapdragons. But if it weren't this, probably this laptop would be running Windows. So yes.
Yeah, they still I think are actually from that perspective. This is the time when, so if we talk about Coffee Lake, this is the time when slowly but surely AMD creeped in with the Ryzen series. This is roughly the timeline when Ryzen came to the market. I can recheck that, but I'm pretty sure it's that.
It was the time when nobody was taking Ryzen seriously. Because everybody thought that what Intel was doing made sense, and this was the first introduction of the Ryzen line, probably.
Yeah, Ryzen 3rd gen was 2019, so yeah, this in the same time, 2017, roughly that.
And this was when people started paying attention to Ryzens. The reason was that it's not the performance itself. Performance was much better than the Intel, but the reason was not the performance. The reason was the pricing.
AMD went back to its factory default mode from the early 2000s, I think. And coincidentally, the last time when they did that, which was probably
Early 2000s.
Thunderbirds and Bartons, 2500 Barton and the early Thunderbirds. That's when they were super popular on the market because of the pricing, if nothing else. I think that they went back to the drawing board, made CPUs that kind of mimicked that aura or that energy or that whatever you want to call it, that era, and they steadily built on top of it and made quite a bit better CPUs than Intel ever since then.
I would say that they suddenly stopped trailing and started leading the market.
Yes.
And this was done basically overnight.
Yeah.
Overnight. They just came with a new architecture. This architecture worked. It was cheap. It was supported by motherboards that were stable. And all of it made sense.
Actually, I have a little bit of a bad memory for the drivers for the motherboards from that era.
Okay, but this is
at least at the beginning.
Yes. But also, let's try to ignore the thing that currently is happening in the GPU market, with Intel trying and failing to create drivers for their own graphics card for the last couple of years.
I would disagree with that heavily because since we did the episode about their GPUs, which was a year and a half ago almost, they steadily improved all of their ARC drivers. ARC is now a very good proposal. You wouldn't believe the amount of additional performance they eked out of the card, but just by improving drivers.
Okay, but they had to improve the drivers because you wanted a system that is stable. So
I know.
Not crashing. So it's an improvement. Okay, but let's just say when I was asking this, I was posing this question to the ChatGPT to tell me which were the next generations when after the Coffee Lake. Even ChatGPT decided that they're going to just shrink everything into just noting the next generations because nothing happened of note.
Coffee Lake Refresh was less than relevant, which was ninth generation.
No, I would let's call the Cannon Lake. The Cannon Lake was one of those things when Intel started showing its age. And the Cannon Lake was coming back to disaster that came with the trying to upgrade the Pentium 4.
Okay.
Because they tried to move to 10 nanometer process.
Didn't work.
Failed. And then reintroduced Comet Lake. That's going to be that was going to be, but it was
Gen 10,
14. But it was 14 nanometers. So they tried the technology, it didn't work, failed, and then went back to the old technology and reiterating what they had. And the problem was that AMD was then faster. So it is the 10th generation. It was faster, it was more stable, and it was much cheaper.
Yeah. And suddenly, much better thermals.
And this was something that was a big problem for Intel back then.
Yeah. I mean, in the Gen 9, you can completely skip nothing of note. Actually, literally nothing to write home about. Gen 10 was the Comet Lake, as you mentioned. As you said, 14 nanometer, 10 nanometer, 14 nanometer back. And they didn't find their way back, just started doing the Moore's Law pushing, scaling in that direction, added more cores, added more threads as a result of that, enhanced the turbo boost. Technology started supporting higher frequencies of DDR4 2933 or something like that. And they made an effort in terms of improving the chipset part of the story and the integrated controllers part of the story of the Comet Lake, Wi-Fi 6 support, Thunderbolt 3 built-in support, blah 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 blah. Some of those things. This specific generation, so 10th generation, did offer, let's say, a notable speed bump. But that speed bump was not necessarily a real thing. It was just more cores were added to the CPUs of when compared to the previous generation within the realms of the same price tag.
Also, but the thing was that the speed bump was related to the previous generation of Intel.
Yeah.
It wasn't the speed bump when comparing it to AMD, and this was a big thing, a big problem for Intel. Even the bigger problem for Intel is that when they try to do something, they had to reintroduce something mobile focused. So they created Ice Lake, and the Ice Lake was introduced the same year as the Comet Lake, and it was basically the idea of trying to do something for the laptops because they were seeing that they're going to be losing the market share. The market share wasn't lost that much when it came to what the AMD was doing, but the writing on the wall was that somebody is going to skip the Intel bandwagon. So this was the time when, obviously, inside Intel, people realized that Apple is going to go away.
Yeah, this is exactly that crunch time. The Coffee Lake refresh. That's where it was obvious, and the rumors started swirling that Apple, is going to switch to their own designs, which they did, and quite successfully so. Actually, I was very surprised, as I mentioned in one of the early episodes of the podcast, that they were able to manage to do that so successfully. A, B, so functional. C, even the old code worked really well via the built-in emulators and registers in the CPU. And I found the architecture, when I looked at the tech specs into, let's see, a little bit more deeper into the what we now refer to as M1, I was very pleasantly surprised that that Apple saw the light at the end of the tunnel, and they made a CPU that was completely logical in terms of the design, performance, thermal envelope, pricing, whatever. All of it kind of fit. And to this day, I'm standing on that hill saying that they made the correct decisions.
It was entirely a correct decision. But the thing is that in 2019, M1 was introduced in 2020. So a year later.
Yeah.
But if you are a chip manufacturer like Intel, and you have a major partner like Apple was at the time, you can see that your partner is no longer ordering parts in advance, because those parts are not ordered overnight. You are not going to do the orders for the next generation laptops a week before the launch.
Especially having in mind that they had some exclusive arrangements in which Intel produced some of the chips only for Apple.
Yes, so the thing was that Intel knew what was happening, and they decided to basically flail their hands in the air and try to make things better. So they introduced Comet Lake in 2019, Ice Lake in 2019, that is mobile focused. The idea was to try to do whatever was possible on the new technology, because Comet Lake was 14 nanometers, Ice Lake was 10 nanometers.
Finally.
So the redo of the launch. They introduced Wi-Fi 6, so this was part of the technology.
This was available earlier as well. But
and this was the idea of being native Wi-Fi 6, because they wanted to grab the laptop market as soon as possible, since they wanted to cushion the blow that the Apple did. And the blow was much, much, much bigger than anticipated, simply because obviously, I have a laptop by Apple.
Yeah, these laptops are super successful.
This was probably the most successful laptop that I have seen in the last 10 years.
Agreed.
Okay, right now, I can see Framework becoming a laptop that is going to be...
I would very much like that.
Yes, and the reason is that I saw a test that said, okay, Framework is slower than the M3 generation of laptops, but it's half the price. So price-wise, right now, we are not talking anymore about the Apple. But when this came out, for the price and the performance that it had, and for the battery life, this was and is the best laptop that you can buy.
Yeah, we still stand on the hill of saying that the base models of the laptops...
This is the base model of the M1 Air.
And the minis as well are the best
buys. The base model of the Air is currently the best buy still. Even though the Apple removed it from the lineup, but you can still buy it in retailers in the US. So this is one of those things that is going to be around us for the next 10 years or so. Yeah. But okay, then came the Rocket Lake.
Yeah,
Rocket Lake was.
We are done with the BS. We are moving in the right direction, Kala.
Yes,
finally.
but it was the Rocket Lake was the last one where we said this is going to be the last one, because this was when they said, okay, we are going to be still improving the performance and so on. They reuse the 14 nanometer technology. They were trying to compete with the AMD Ryzens that by now went into the 5000 series. So the competition was extremely tough. And I must say that I like that. I enormously like that because the first generation of Ryzens was okay. The third Ryzen's 1000, the Ryzen's 3000s were amazing. 5000.
You still have that one?
Yes. The 3800, and I run it daily. Basically, it's my second computer, and my primary computer right now is in Intel. So I'm currently running 13700K, and F. KF, and I'm running 3800X as my second computer.
Yeah, I don't have a second computer
The
anymore.
reason why I have a second computer is because I'm obviously the one that is never going to move from one computer to the other the way it should be done. So by turning off the old computer, I still have my files on the old computer, so when I need them, I just log in and grab them. I didn't move. I just created a new computer and then moved whatever I needed. And now my older computer is, I wouldn't say wasting power, because the 3800 is a nice computer that doesn't use too much energy, but it's the computer that is running right now. Okay, so the Rocket Lake was the thing, but also you could see the one thing that was basically prominent. Suddenly, Intel decided that they are going to be naming their cores and their architectures names. Suddenly, this chip itself wasn't the project, the name. So Ice Lake was the chip, but the CPU of microarchitecture suddenly was called Sunny Cow. And the reason why this is important is because the Cypress Cow was part of the Rocket Lake. Suddenly we had a name for the core. And this became important later once the Alder Lake was introduced.
Yeah.
And the Alder Lake was the thing that actually changed the market.
I would actually say that in this generation Rocket Lake, having in mind that they implemented the Cypress Cove architecture, the end net result of that was that for the first time in almost, I don't know, maybe even more than a decade, we could actually talk about IPC improvements on Intel specifically, not on AMD. Instructions per clock, which has become a battlefield in the past couple of years for a reason. There is a reason for that.
Officially, Intel was pushing the IPC improvements in the Ice Lake.
Yeah.
It was one of the things that they said, okay, instructions per cycle are going to be better. So we are going to be dealing with the pipelining and everything else. But in this was the foreshadowing of the introduction of architectural shift that is going to be a hybrid architecture.
Yeah.
Because they had to do something. So what they did is first they named the cores differently, so the microarchitecture, and then when they introduced the Alder Lake, they said, okay, we are going to be combining Golden Cove, and this is going to be next generation, and there's something called Gracepond.
Yeah, let's get to that because there are still things to talk about when talking about Rocket Lake. First and foremost, PCI Express 4 support.
Yes.
Let's say that that's actually important. I'm not being sarcastic, it is important. PCI Express 4 but still is de facto the standard of the market, although we have, as I mentioned earlier, in the previous episode about Intel, it is PCI Express 5 exists, but almost not being used at all. They also, so I would say that this is probably the crunch time after the initial, let's say, frenzy about the NVMe SSDs in M2 format. This is roughly the time when all of the motherboards all of a sudden started having 2+ NVMe slots for M2 slots specifically, which was important as they started pushing new chipsets, again with every single new generation of the CPUs, which we should have a discussion about, but maybe in a different episode. because discussing chipsets versus CPUs, compatibility upwards, downwards, and whatnot is a fascinating topic to talk about, both
Yes.
in Intel and AMD. And there are some very cool things to say, and then also heavily spanking to be made there. But furthermore, they introduced the chipset that they or the CPU of the Rocket Lake generation had built-in PCI Express controller with up to 20 PCI Express 4 lanes, which was quite important. They also integrated USB 3.2 Gen 2 X2, which we now refer to as that 20G USB standard, and they started pushing the new Intel 500 chipset for that purpose. Also, they had that memory controller was completely new. They had better media encoders with Intel UHD graphics, and they started working on some of the primitives for what we are now seeing to be as a AI fight, because some of the registers in the CPU kind of like went in that direction as well. So that was quite a substantial, let's say, substantial departure from the previous generations, where Intel was just basically playing it safe and supporting the basic set of features, and that's what it is.
Let me also mention one more thing. The thing was that Cannon Lake, Comet Lake, Ice Lake, and Rocket Lake were all based on LGA 1200.
Okay.
And the reason for this, why I'm pointing this out, is because the Intel was much more keen to change the socket when it came to newer processors.
In many generations before that.
Yes.
Agreed.
And suddenly,
which everybody didn't like.
Yes.
Nobody
and
liked
suddenly,
that.
when AMD said, okay, our sockets are going to be backward compatible, so you're going to be able to buy a high-end motherboard and then actually upgrade the processor with the next generation of the processor because we are going to say so, suddenly became a thing. And Intel had to keep up with it.
Yeah, because in the good old days of 1150 and 1151 sockets, they used to do that across multiple chipset generations, and then they stopped.
Yes, and this is also one thing where you can see that Intel had, I would guess, I'm not in any way or form connected to anybody in the higher management of Intel, but you can see in retrospective that there were probably a lot of talks when it came to engineering in 2018, 2019, 2020, 2021. Not because of the COVID and everything else, but also because the landscape changed overnight. M1 came to the market, AMD came to the market with a vengeance. Suddenly, different manufacturers of the motherboards suddenly realized that they can support two different architectures that are both going to be good, so that they can sell more units. So suddenly, Intel both lost one of the biggest new customers. Intel lost the market share humongously, and Intel found itself in a position where they didn't know how to read the next generation of the processors.
There was one other very big process that started happening in that era. Do you remember which one? Super important for this story as well.
No.
NVIDIA tried to buy ARM.
Okay.
That's where it started, because that would kind of put Intel in an even smaller corner than what it was.
I think that NVIDIA buying ARM, and now let's play a game of what would happen if it happened. I say that NVIDIA buying ARM would be detrimental to the market. I wouldn't say that NVIDIA...
I think it would shut down x86 in 5 years or less.
No, I don't think so, because what would happen probably is that NVIDIA would suddenly become direct competitor to the AMD when it came to CPUs. And NVIDIA, in this particular moment, NVIDIA was unable to deal with the chipset market, when in the GPU market.
Okay.
It had a huge problem with those huge cards that required enormous amount of power, because this was the time when they were introducing cards that were drawing something like 600 watts. So they weren't prepared to be a player that would play well on the market. So probably the ARM would decline in its share. The way that ARM is
No,
structured...
from customer perspective, it would probably mean, as you said, it would not be good for the market. That's what you wanted to say.
No, it wouldn't be good for the market, and it wouldn't be good for anybody else, because right now ARM is in a peculiar position where they're licensing to almost every living and dying manufacturer of chips on the market.
Yeah.
So there is not a single customer, not a single producer of chips that isn't licensing something from the ARM. So they position themselves in a very peculiar position, which is the good. It's a nice position to be in, but also if somebody buys them,
Which it will happen eventually.
or it may not, because they are English based and they don't have this push for we need to push more units, we need to create something else. They're creating something else and they are not pushing units. There are no units to be pushed. They're not producing anything.
I know.
So this is a peculiarity of the
Yeah, we haven't seen that in forever.
The thing that I was talking to the students yesterday. I didn't have time to talk to you about this. Just as a side note, I am lecturing the computer architecture course at the Algebra University in Zagreb, and I was talking to the students about the way that the entire infrastructure and the entire landscape of the IT manufacturing is right now. United States as such and Intel as such is in a very, very, very vulnerable place. ARM is becoming a major player, or has become a major player on the market. ARM has 90% of the CPUs on the market right now, or the cores, to be more precise. Because for everybody who is not following, they have something like 10 to 15% of the desktop and laptop market, mainly because of the Apple. But they have the entirety of the mobile market. So every mobile device right now on the market is basically based on by ARM.
This, that, yeah, everything.
They are producing both the CPUs, GPUs, controllers, ultra-wideband, Wi-Fi, all the controllers, sensors, GPSs, and everything else for the mobile market. They're producing the enormous amount of controllers for everything else, the televisions, tablets, set-top boxes, and so on and so on and so on. So they have a huge part of the market. They are not manufacturing anything. Biggest manufacturers are based either in Korea or Taiwan. So what is left, or China? What is left for the Intel and the United States?
Hence the reason why NVIDIA wanted to buy ARM.
Yes.
Strategic positioning.
And this is the reason why Japan has decided to invest heavily in the new IT.
So did US. Very same reasons.
Yes, but this is a thing that hasn't happened ever.
There's one other thing that happened, I think last year. Maybe you missed that one. Do you know who joined RISC-V consortium?
ARM?
No.
Obviously, I didn't pay attention. So
yeah, Intel was actually a part of it for a couple of years. I don't know if they're still, but I know that they joined RISC-V consortium as well to kind of explore the capability of producing chips.
But they have to. They have
of course.
to. There is only one way to keep Intel on the market right now, and
corner everything with every architecture.
They need to diversify, and they need to diversify heavily. And I think that what is happening right now with the CEO of Intel, who is a major player and is probably one of the wisest guys when it comes to planning and executing such shifts as he needed to do, because he was the one, Pat Gelsinger, he was the one who was the CEO when all of this came to fruition and everything was basically in complete disarray.
Shambles, yeah.
So he was able to pull the Intel boat out of the mud and try to make some sense of what they need to do. So suddenly we have a huge shift in what is happening on the market. Suddenly Intel is not that Intel is suddenly in a
much
position.
More aggressive.
No, but it's not that it's the Intel itself is not that important anymore. AMD is not that important anymore. ARM is the most important manufacturer right now. So AMD has been aggressive. Intel was trailing behind. They need to become aggressive as soon as possible. They need to build up the ability to, they need foundries because they need the ability to manufacture. They're trying to do this, so Intel first and everything else, the idea.
And the high-NA chips, the high-NA machines that they bought from certain Dutch company.
Yes, but
ASML.
this was my next thing.
Let's leave that for the outro of the episode.
No. Just let's make this in the outro.
No, we still have a couple of architectures.
Yes, I want to just say one thing. The manufacture of the machines that are able to produce the chips is based in Europe. So
Intel co-owns that manufacturer.
Yes, but still, it's based in Europe. So the machines are manufactured in Europe. Still no dice for Intel in the United States.
Never mind. They got the first machines of the latest generation.
Did they?
Yes.
How many of them? 3 or 4?
Maybe even less, 1 or 2. But they are very slow to produce them. But I think from the news that I read, they got the whole first batch.
Okay, but I think that the numbers that they're talking about is something like 360 wafers per hour.
Okay.
So we are talking about low 4-digit numbers of chips being able to produce every hour.
Still better than anything that they have.
Yes, but the thing is that they are extremely slowly ramping up their production in the United States.
Because they're dependent on other production methodologies, which they didn't
and
use in the past.
This is something that has come to bite the proverbial backside of the Intel. I think that you could call it not investing in R&D and also not investing in what was happening in the market, because up to 2017, it looked like the Intel was the king. They even tried to create we forgot all the other ventures that they are trying to keep behind the closed doors, since they completely lost it. They tried to create the chips for the phones. We didn't mention those because
they're abysmal failure.
Abysmal failure. So the SPV and everything else that came after this. So they were trying to create tablets, failed. Laptops didn't fail, but didn't work as well. Desktop, okay. Servers, okay. But as soon as the EPICs came out, suddenly the core counts that the EPIC was able to provide was nothing compared to what Intel was using. So for a given amount of money, you could buy 2 or 3 times more cores for in the same form factor as Intel. So suddenly Intel was...
It wasn't that much of a price difference. It was about, as you said, it was about the density more than the price. And density is important, of course.
But density is probably the most important thing. Especially
if the operating system supports it, which we will discuss in some of the future episodes.
Yes, let's leave aside for right now the complete and utter failure that is Microsoft and trying to support how the
many core architectures work,
how architectures were developing, and suddenly realizing that, oh no, somebody has 16 cores. What are we going to do now? Oh no, they have 32 cores. 60? Oh, come on! And this is what
Linux is the same.
Linux is the same, but the Linux, when it came to number of cores, they realized that it is going to be exponentially better, and then they quickly switched. Microsoft is moving like, I would say, motor ship in front of a bridge. They are completely unable...
Not the best metaphor in the past couple of months.
Yes, but I see that the way the Intel and Microsoft were being steered is more akin to the bridge and the ship.
Okay.
And Microsoft still needs a lot of time to reintroduce everything that they need to reintroduce in the new, especially on the server part.
Okay.
But anyways.
Okay, 12th generation is next. Older like...
Yes, but 12th generation is fun.
It is. 2021. COVID era.
2021, immediately after Rocket Lake was in the market, Intel realized that enough is enough. They need to do something.
Hybrid core architecture.
So hybrid core architecture. Let's break it down for everybody who is not paying attention. Suddenly, Intel doesn't have 8 identical cores in the chip, or 16 or whatever number it is. Suddenly, we have cores that are different. So a single chip has multiple cores, and those cores can be divided into different groups. At first, it was two. It was something that was called, in some way, performance,
And efficiency?
and the other was efficiency, or however do you call it, because they use different nomenclatures, and they said, okay, this is going to be a performance, this is going to be power saving cores, this is going to be an application core, and so on and so on. But the idea is one core is bigger, faster, and is using much more energy, and another core is smaller, slower, but uses much less energy. So it is something that can be actually used in a laptop in a way that it can save energy, and also this makes desktop computing much more energy efficient.
Basically, it's a copy-paste of what mobile technologies have been doing for many, many years.
Yes, and also they were starting to show that they care about scalability and that they care about power efficiency. And this was something that was extremely important. If this didn't happen, Intel would be done by now.
DDR5?
DDR5,
PCI
Express 5, 1700 socket, new socket for the entire thing. Also, humongously more power efficiency, so not wasting that much energy. Also, big problems with the operating system.
Oh, the thread director and all of those
The
things.
director, the Windows 10, the CPU
11.
IDs, Windows not being able to recognize this as a single PC, but recognizing two different processors, not being able to schedule things in cores, suddenly some applications failing by just being able to see part of the processor, not seeing the entirety of the cores and everything else.
You should see Task Manager in those earlier versions of Windows 10 and 11, for example, for those new CPUs, what it looks like. And conversely, to the other topic that Yasmin just covered, you should see the way in which Task Manager looks with, for example, AMD EPYC of 256 cores or whatever it has.
Yes, the interface itself is completely broken because nobody realized that you can have an actual 256 cores in a single computer.
Or 128. Yeah, nobody cares.
I was showing yesterday. I was doing a Linux course, and I was showing to people how HTOP looks like when you show all the cores in 128 core EPYC, and it is not.
It's not readable.
It's not a nice thing to see.
Yeah, it's completely a mess.
The thing is that suddenly, what made me happy about all of this, and right now I'm talking about specifically objectively, subjective me. Suddenly, everything was happening. Suddenly, we had.
They were first with DDR5, first with PCI Express 5, so Intel back to forefront in a way.
Yes, but suddenly you had a huge boost to the speed of the disks. You had a huge boost to the power available on the laptop market. You suddenly had a huge competition between AMD and Intel. You suddenly had cheap processors that were much quicker than the previous generations.
They were quite a bit cheaper than previous generations.
Because they had to do it.
Yeah, they had to do it.
So suddenly a user or a consumer was able to buy much more for less.
When I bought my 3900K, I was kind of comparing from memory, because that's basically the highest end chip of that generation. It was something like, I think, less than 400 euros when you deduct the VAT. So maybe 420, 50, 30, 50 euros with VAT. That was basically one half, or even less than one half of the price of the what used to be one of the extreme editions of many generations ago, or some of the highest end CPUs of the previous generations. I was very surprised that CPU was, compared to Intel standards, was much, much cheaper. The motherboards were very expensive though as well. That's another story, because with these latest 2 or 3 generation CPUs, so 12, 13, 14th gen, when you start buying the motherboards, you probably want to buy a little bit more expensive motherboard. A smart decision.
Yes, but right now, especially on the AMD side, it makes huge difference.
Yeah.
Because if you are buying a better motherboard, you are going to be able to keep it if you change the processor.
You can do it with the Z690 as well.
Yes, and still the thing is that when I was thinking about when I was upgrading the last time, suddenly I had to make a decision. Either I'm going to be buying the most expensive motherboard with all the different features and the quirks, or I'm going to be buying a middle of the road motherboard and then not even counting on upgrading it. I chose the latter because the thing is that I didn't want to have a future-proof motherboard, since I don't see a reason for anybody buying a second-hand CPU from me.
Okay.
I wouldn't buy it.
Okay.
So I
wouldn't buy from you as well.
No, I wouldn't buy for me at any given time.
Just kidding.
But the thing is that what I expect to do is I expect to always do an upgrade to the motherboard, CPU, and the memory. So I'm not going to make those into different parts. I'm just going to say, okay, I need to upgrade my computer, so everything's going to get upgraded. Especially with this speed of technological advance that we see now right now.
Yeah. Okay. I'm basically, the 13th gen is just a refined version of the 12th gen, what it was. A much wider adoption of DDR5, PCI Express 5, still not being heavily used. I was only recently, a couple of months ago, 2 months ago, I was able to buy a PCI Express 5 SSD. Luckily, I bought myself a pretty expensive Asus motherboard that has that PCI Express controller in which you can put PCI Express 5 and 4 SSD at the same time, and I'm able to use that in my computer, which makes me very happy. The PCI Express 5 SSDs, especially given a little bit of time to develop, there are already models out that have 10 gigabytes per second plus transfer speeds, which is what the market is asking for, so that's good. It's just that the motherboards are still super expensive, while to kind of like go back to the topic which I covered multiple times, motherboards are very expensive, not expendable, and they're lacking a lot of stuff that they should be having. It's just inconceivable that you buy a motherboard for 500, 600, 700 euros, dollars, whatever, and you don't have, for example, Thunderbolt. It's just not acceptable anymore.
Also, the thing that I'm seriously lacking right now, I'm using an Asus something Pro. The idea of having a single USB 3C connector is something that I am completely missing the point why this even happened.
Yeah,
I was just looking at the motherboard yesterday because I wanted to plug in a second USB-C cable, and I said, okay, why do I need to have a USB hub in order to do this?
No, you need to have a Thunderbolt dock.
Yes, but why do I need anything else other than the motherboard? The motherboard
Exactly,
should be
back
able
to my rant about the motherboards. That's exactly the reason why that pisses me off to no end. I mean, it's just inconceivable to work in that way. It gives so much money for a computer. Not having enough USB ports is just not the thing that we should be discussing in 2024. The latest gen is 14th. I don't think it deserves more than one sentence or two. It's just a refresh of the existing technology, which doesn't offer all that much. That's it.
I would say that 14th generation doesn't make too much sense to if you need to buy a computer. For the upgrade.
The top end CPU is roughly around 550 euros, something like that.
But the thing is that when we come to there is also one caveat. If you remember, there was it was a recall. It was a voluntary change in configuration for some of the motherboards that basically means that you get a slower processor because they were too optimistic in overclocking the motherboards.
You mean this one from last couple of weeks?
Yes. For the 4900K has
Intel says it's motherboard manufacturers.
Yes, but I don't care who did it.
Yeah.
The thing is that I have whoever bought the highest end CPU suddenly has the CPU that is 10% slower than it used to be, simply because somebody made an error.
AMD had much worse problems with 3D cache CPUs last year. Those problems were much worse. They're basically burning the motherboard, physically burning.
And nobody was completely honest on who burned who.
Yeah.
From what I remember, that AMD was pointing at the motherboard manufacturer that the motherboard is burning the CPU, and the manufacturers, let's not name them, were saying that the CPU is burning the motherboard. I would, if I need to call, I would say that the motherboard manufacturer is probably on.
I don't know. They made a firmware update, which seems to make things better a couple of months ago, but it was shambles. Some of the things that happened with Asus in that specific situation was covered by many YouTubers. I don't want to get involved in that discussion, but yeah, it was quite worrying. What we are left to talk about in terms of the Intel CPUs is the next generation, which is rumored to be released near the end of 2024. From what I was able to find in terms of the leaked information, rumors, whatnot, is that they are even more betting on the hybrid architecture. They're moving to tile-based methodology, and these are supposedly the first CPUs that Intel is going to make with the built-in memory as well. So
yes.
going the Apple M1 to freeway, and I think parallel to that, AMD should also be releasing something very similar to that.
But 3D was the one of the steps in this direction. 3D was okay. It wasn't the memory; it was the cache. But the idea was to probably see if this is feasible.
Okay.
On the other hand, I see a big problem with this because if you stack, okay, let's talk about what 3D is.
3D cache.
So instead of having a planar CPU and having your CPU in the middle and usually the cache in the somewhere around the CPU because you need the way to talk to the CPU to the cache.
Equidistant.
Equidistant. Okay. So you need some way of talking to the cache. You can either put the cache around the CPU or you can put it in the middle, but you do something to the CPU. Whether it's going to put some sort of an illustration for the EPIC or for whatever the generation of the processors there are. So instead of doing this, what you do is you put your cache memory on top of the processor. So suddenly your processor is smaller, and suddenly the cache is closer to the CPU core, and it can be used better. This is the first thing. The CPU itself is smaller, and it's easier to produce because you're producing two different layers, and then you're stacking them together and basically gluing them together in a way. I'm
oversimplifying, but yes.
I'm oversimplifying, but this is the idea.
But the technology problems with that.
Okay, but I see another big problem because if you have stacked the CPU and then the cache on it, how do you stack another set of memory on top of all of this?
It's not only that. You should try to make that as a technology exercise and try to cool it down because the caches are the part of the CPU that heats up very quickly, and that's responsible for the large portion of the TDP of the CPU as an analog component that consumes so much space and quite a lot of electronic elements. That's one of the technological issues there. I'm very much looking forward to these next generations, especially for the built-in memory, because as you mentioned, I want to see how they implement that from the perspective of the architecture, which is always interesting for the both of us because of the class that we do, but also I want to see how that performs. And thirdly, somewhere in the future, I would be very interested to know if they're going to do some kind of a, let me be stupid, ZIF socket or something like that to add memory.
Yes, there is a socket. There is a new socket for the laptops that was done by Dell.
Oh yeah, I saw that.
Yes,
for laptops.
Yes, because they were specifically targeting this problem because they don't have any idea on how to deal with DDR5 when it comes to memory in the laptops. Since the laptop memory doesn't have enough space on it for all the lanes that they need.
And voltage regulators, and probably, voltage stuff like that. Yeah.
So they basically what they created is something called that was akin to AGP. They have two stage pins on the memory.
AGP, yes.
Yes, if you remember this. But the thing also that I want to mention is that there is something about the framework laptop that makes sense now, even more than it did any time before this.
Okay.
Because the framework laptop. The idea is to have a modular laptop that you can actually exchange every part of. Suddenly,
which we like very much.
Yes, the idea of okay, we liked the modular idea whenever it was introduced, but it always failed for the simple reason of that the different architectures were so different across the board that you couldn't simply create the backboard or the main board or the daughter board or the motherboard itself in such a way that to interconnect everything and still retain the compatibility with the next generation. Now, this is completely feasible. First, you can buy older processors for much cheaper. You don't have so many changes across the architectures. So suddenly a modular laptop makes sense. And this is, as I said, for the average consumer, this is going to be amazing.
I already had a modular laptop, but not up to that level. I talked to you about my Red Toshiba. It had 2 slots, which you can. One of them was for CD-ROM, one of them was, for example, for TV tuner, and I could easily remove them and put other modules in, and there were like four or five modules. But we are now talking about something that's modular to the max.
Okay, but
it's not the same. But
let's be completely honest. Back way when Jesus was still walking on the earth, we had modular Amigas that were able to be.
We had PCMCIA as well and PC card.
Also, we had the Apple IIs that were able to be upgraded to different CPUs. So I'm hoping, and honestly, I'm hoping that somebody is going to create a PCI Express 5 card with ARM processor on it. Yeah. So I would pretty much like to see.
That exists.
Yes, I know it does, but I want something that's going to be mass-produced and cheap.
That's cool. Okay. We reached the end of the architecture part of the conversation, but now that we are done with that, you raised a couple of interesting points. I kind of played second fiddle to that. I want to reiterate them or kind of like go back to them. And I want to revisit some of the topics that we covered in some of the previous episodes because before we close this down, because times have changed since we did some of those episodes. Actually, some of the recent ones are already not up to date, which is the fact of life. It just happens. First topic that I want to talk to you about, which I ridiculed you about in a ridiculous fashion, just for fun, is Windows on ARM.
Yes.
We need to go back to this discussion, and this is the perfect time. Reason being that Intel and AMD, being x86 players, are most probably soon not going to be the only ones with Windows.
Yes.
And I want to pick your brain and have a little bit of a discussion about what do you think that means for the market? Because, again, I was ridiculing you for humor purpose. I was very much aware that you're correct. And I agree with you on that.
I see that Microsoft has been heavily investing in trying to diverge as much as possible from Intel. They are trying to create a complete ecosystem. Right now, they don't have it, but they did whatever they could to create an ecosystem based on ARM. So they created the Project Volterra hardware. They actually created a PC that you can buy. It's $600 still. It's now 2 years old, I think, but you can buy it. It's a pretty decent developer machine. It is not that expensive because $600 is not expensive for a machine that has 32 gigabytes of RAM and is based on ARM. So it's a decent machine. They have a Windows 11 for ARM. They have Visual Studio for ARM.
Okay, for years.
Yes, but Visual Studio is right now native on ARM completely. So they are not running it in compatibility mode anymore. They used to, but they're now completely native. They're able to natively compile .NET. They basically created the entire ecosystem from their part. So SDKs are available for ARM. Visual Studio is available for ARM.
They actually have a compatibility layer for x86 as well, in the vein of Rosetta 2.
So what they are trying, also the ARM structure, also the architecture has the compatibility layer that enables you to basically mix and match ARM code and Intel code.
X86 code.
Yes, so in x86 and ARM code. At the same time, in order to be able to run as quickly as possible, if you have some part of the code or the libraries that are written from the ARM, so you can mix and match everything. So Microsoft has shown the ability to shift to another architecture. This is not something that they would do lightly, because they have multi-billion dollars contracts with Intel. So this shows that Intel needs to do something, but also this is going to be enormously entertaining and useful for the consumer.
A month ago,
yes,
I read an article about this topic. I was saving it to comment on till today. That Microsoft is really betting big on the latest Snapdragon X Elite CPUs, which are ARM-based, and that with Windows 12 probably, they're going to release the Windows on ARM with having these CPUs in mind, that they're also going to launch their the Surfaces with that CPU, and with Windows on ARM natively, of course, installed on top of them. That's what I want to see.
Okay,
I know it's going to happen.
But Surface is also already on ARM.
I know it has been, but nobody is buying that.
But the biggest reason is that if you are buying a Surface, you are going to pay as much as the regular Apple, and you are going to get a much better laptop for the on the side. Because the thing that is right now lacking on the Microsoft side is the ecosystem.
Yeah, Windows
did,
RT are not necessarily something that you want to have on your.
Also the applications.
Yeah, exactly.
What Apple did is that they prepared the ecosystem.
Yeah.
As soon as you got the laptop, everything was available. There was not a single application that you weren't able to run.
Hence the difference between what we are discussing today, which is having x86 and ARM for desktop, for server, for whatever type of workloads. If that happens, which I'm pretty sure it will, versus when we started our IT journey 30 years ago, because back then we were kind of betting on which architecture is going to win, which ISA is going to win, the instruction set architecture, although it was pretty clear that probably x86 is going to stick around for a longer period of time than some of the competitors. But still, this is quite different, because now we are at an age where, let's say that you're a regular Joe user from the street. If you have a laptop that has 20-hour battery, operating system that works, Word, Excel, Internet, and all of the most common features working on Windows on ARM, and if it's even better, if it's cheaper than the comparable x86 laptop, no reason why not to buy it. That's what future holds for us, that type of discussion.
Also, the thing that is important is that Microsoft has all the reasons why they should do that, and none of the reasons why they shouldn't. They had this idea of not muddying the water and trying to change the architecture, because there was no clear competition to the x86. So they decided to stick to x86. When it came to switching from 32-bit to 64-bit, even then they waited for enormously long time before they switched. So you had 32-bit and 64-bit versions of the operating system at the same time, because they weren't completely sure. Now they are doing the switch before the processor is available. So you don't have the devices, but you have the operating system. The only reason why the operating system that is on ARM right now is not working on anything else other than the Microsoft-supported devices is probably the same reason why Apple is not releasing the operating system for everybody else other than themselves, because it is the stability part. They could probably they can make the Windows 11 run on Apple hardware, but they don't want to. I would
might change in the future. You never know.
Because it took Avahi Linux 2 weeks or 3 weeks to be able to run on Apple hardware.
People are running Dockers and whatever on their M1s since a couple of months after the launch of M1.
Yes, and so this is but what makes me happy is that suddenly for sub $1,000, you can have not a decent machine, but an amazing machine available. This wasn't something that was available a couple of years ago. A couple of years ago, machines that were able to do, I would say, decent graphics and amazing performance when it comes to CPU were much, much, much more expensive.
I agree with that as well.
And the only thing that is missing right now is to see NVIDIA support ARM.
They already support it, but not necessarily on the markets that we talk about.
Yes,
That's
and
the first problem. And the second problem, as evidenced by Mac Pro, PCI Express on ARM is a topic that we are going to be discussing for the next years.
also, I'm with a little glee, I'm waiting for what is going to happen when AMD has to support ARM.
Drivers for GPUs?
For GPUs, yes.
Oh, yeah, that's going to be fun.
Also, seeing ARC on ARM is going to be amazing.
NVIDIA has years of experience of developing for ARM. They have their own platforms
Yes,
for
but
that and whatnot.
Intel
But
has
these
years
two
of
don't.
experience developing for x86, and they're still failing with the drivers.
Yeah, but not for the GPUs. It's different when we talk about these types of things.
But yes,
principle stands.
Yes, they are developing drivers for their own architecture, and right now they're going to be needing to develop for additional architecture that's not theirs. This is going to be fun.
Okay.
But as I said, diversity is okay. I want to see more diverse ecosystems when it comes to everybody on the market. So everything that can be introduced is fine.
Okay. And to wrap this up,
Yes?
I have a question for you.
Oh, no.
Yeah, it's simple. So we did, I think, 6 episodes of Intel covered all of the generations. If you were to pick and select your 3 most important CPUs from all of those episodes, you don't have to have the specific model name, just the generation. Let's say Pentium 3, stuff like that. Which ones would you select?
I would go with 486.
Okay.
Then probably Core 2 Duo.
Okay.
And then probably the one that I'm using right now, the 13th generation.
Okay.
Simply because they were the polished releases of the technology that was available at the time.
Okay.
So they were the biggest steps forward when it came to technology, but also the ones that worked.
Okay. I would second your 486. I would say Pentium 2.
Okay.
Or if you wanted to harp on that drum, for me, Pentiums 3 and 4 were even more important than Pentium 2. But for my personal selfish reasons, Pentium 2. And after that, let's see. For me as well, the 13th gen.
The 13th gen is the one that actually showed that Intel is capable of doing something.
Yep.
It wasn't expensive. It was competitively priced and competitive performance wise. So this is one of those things where actually this architecture got me back to Intel. I was using almost
overnight he told me he's buying a 13th gen Intel, although he had Ryzen at home. Just for perspective.
I had a couple of Ryzens at home.
Yeah.
I had a first generation Ryzen, then the third generation Ryzen. I had 2 or 3 generation Ryzens. I was running 3600 and 3800 at the same time.
But you surprised me very much when you said I'm going to buy a 13th gen Intel.
This is because I'm completely architecture agnostic if it works. Mm-hmm. I wanted to see how stable this is going to be, and from what everything that I saw, it is one of the stable architectures that are available right now. Okay, it requires Windows 11. This is another point that we need to address. But now, after a couple of years, I only had probably 2 or 3 problems with the stability of the operating system, and this was mainly caused by Microsoft trying to push changes for no particular reason at all.
Especially in the multimedia systems.
Yes, but this is something that is going to be even more pronounced in the next couple of weeks or couple of months, since we are going to be forced to switch to new teams. Mm-hmm. And new teams, for some reason, are changing multimedia part of the Windows.
Yeah.
And I have absolutely no idea why Microsoft is still pushing that crap on the consumers. Because suddenly, as in immortal words of Linus Torvalds, you don't break user space. Mm-hmm. I'm not going to go with the entirety of the iterate, but you don't break user space. For some reason, Microsoft does not understand that there is a kernel space and a user space. You don't break user space. You don't mess and create an application that is messing with the kernel and the user space at the same time.
Okay, and the last question,
Yes.
now to be a little bit more specific, we talked about the generations. Same question, but if you have a specific model of the CPU. Because my answer is going to be different to the previous one.
This one is hard.
Yeah.
This one is hard because I would say 48650.
Okay.
I would say
That's a DX2.
yes.
Okay.
I would say Core 2 Duo, but I don't know which one to choose.
The cheaper ones or the more expensive ones?
The cheaper ones.
8300 or 8400. There is nothing else there. Because those were fantastic CPUs.
Probably 8400.
Okay.
Later I had the 640, but this is something else. And then, as I said, probably the one I'm using right now, 13,700.
Okay. For me, it would be Pentium free EB versions. Specifically 800 on the EB version, 133 megahertz bus.
Okay.
Absolutely, it would be Pentium 4 Northwood. Specifically, the most important one was 2.4.
Okay.
Not the later ones, which were, yeah, you know. And after that, 3900K. Nothing in between was ever remotely interesting to me as something of a memorable model, specific model.
But
So you can imagine the gap between those. We're talking 2000, 2001, 2003, 2004, and then we're talking 2022.
yes, and the problem is that if I had to choose, I would probably go with Athlon somewhere in the middle.
Yeah, not talking about that, but
Yeah, yes, but
I
yes,
know.
but the thing was that when it comes to technology, price is important.
Yes,
Also, innovation is important.
yeah.
And right now we are living in interesting times, and this is going to be fun. This is
No,
going to be
actually, the
immensely
next
fun.
couple of years, I think, are going to be by far the most interesting in the past, probably 30 years.
I would just go ahead and say probably the most interesting when it comes to computing ever.
Yeah, quite possibly.
Since we are now seeing computing becoming completely
Agnostic?
not only agnostic but completely so cheap that is completely available to everybody at any
Hopefully.
given price point. So you can buy a IT solution to any problem on the market right now for under $100. I wouldn't say that you can buy a solution for AI, whatever.
Which is where the industry is going.
Yes, but I'm talking about end user consumer. You can buy if you need a desktop that's going to be cheap. You can go as cheap as $70 for the entire desktop, new.
With the monitor.
No. But you can stick it on any monitor, and you can use the PC that I showed you, the Intel's N 4000. But the idea is that you can buy extremely cheap computers, and suddenly we have come to a point where the usual price performance and what you get for a given amount of money has completely shifted. If I told you 10 years ago that you can buy a working system for less than you would pay for your mouse, you would say that I'm insane. But it is completely possible right now. And this is some of those things that didn't make sense back way then, and now they make sense.
Yep.
I know that when I was doing something, by something I mean trolling people using technology. One of the things that I did is that I got a Cisco phone, and then you remember so it is not Cisco, it was the Linksys. When they bought Linksys, so it was basically a Cisco phone, but it was a Linksys. You remember those phones that had a huge
display?
No, the huge leg behind it. So
yes.
it wasn't part of the plastic, but it's a huge basically leg. So the phone was more or less stable, much better than what Cisco was doing. for less money. What I did is I put a Raspberry Pi running Asterisk inside this leg, so the phone became the PBX.
PBX, yeah.
And this was
Awesome.
one of those things. And now you can do this basically for any application. This was just a way of trying to say, okay, I created something amazing. Now you can do it by using Dockers, more or less on any part of the infrastructure that you have. I wouldn't be surprised that the next generation of the mixer is going to be able to run Dockers.
That would be awesome.
Because the power is here, the capacity and the performance is here.
But I think this one has ARM inside.
It probably has.
Yeah, but I'm pretty sure.
And I would say probably not more than one.
Yeah, that's also possible. Agree.
I wouldn't be completely sure that each channel doesn't have its own ARM.
Possible.
The thing that I'm always using when I'm talking about ARM, and I'm trying to see how ubiquitous they are, I'm telling to people or to the students that if they have Apple's headphones, the AirPods Pro, they have an ARM processor in each headphone and in the case. So they are running a multiprocessor system that is headphones.
Yeah, excellent. Okay. We are done.
Thank you.
It's been a long journey. Talked about everything we wanted to tell so
and
far.
We are finally finished.
Oh, yeah, he's so relieved.
Yes, I like Intel, but my problem is that I want to talk about new technologies.
We just did.
Yes, and the thing with that is happening right now is that we are still waiting for the push to the new technology. The ARM is probably being the best part of it, but unless we see enough applications for the desktop, and I'm not talking about applications for the mobile phones, but for the desktop, this is not going to be a journey that's going to end well.
Okay. Well, thank you for sticking with us through all of these episodes. We'll see you in the next one. He's been Yasmin. I've been Vedran. See ya.
Bye.